Good afternoon, everyone. Welcome to this third workshop in a series of Introduction to Data Science workshop series put on by the KAUST Visualization Core Labs. My name is Dr. David Pugh. I am a staff scientist at the KAUST Visualization Core Laboratory, KVL, and I am also a certified instructor with software and data carpentry. Software and data carpentry are two global nonprofit organizations whose goal is to teach foundational scientific computing, data science, and machine learning skills to researchers in academia or industry, really anybody who is looking to get started on the right path with scientific computing, data science, and machine learning. So today's topic is going to be an introduction to Python. So our previous two workshops started with an introduction to Shell, and then we built on that introduction to Shell, and I taught you an introduction to Conda, which is a tool for managing your Python and other languages, but we were using it primarily for Python software stacks. And it's the tool that you will need to use to install all of the software that we're going to use this semester kind of locally on your own computers, laptops, workstations, what have you. But you can also use that tool to install software on remote clusters at maybe your university or your company or in the cloud. So that was last week. This week is going to be about Python. And I really kind of want to get moving because we have a lot of material to cover. And I know everyone is typically very excited for the Python course. Relative to some of these other tools. Although Python, it's important to remember that Python is only one tool in the toolbox, and you do need to have some level of fluency in other tools as well to be as productive and effective as possible. But today we're going to talk about Python. So we're going to be using the plotting and programming in Python notes. These are developed by the software carpentry community. I myself have contributed a fair number of content to these episodes. Now, if you glance through, you can see that there's quite a lot of material to cover. And in fact, typically this would be a full day workshop to cover all of this material from start to finish without skipping anything. So obviously today we do not have a full day. We only have about half a day. And so what I will be doing is jumping around quite a bit in these lectures. So I'm going to pick and choose the topics that I think are the most, not necessarily the most important, but the ones where I feel like you will benefit the most from having my instruction. So if I skip a lesson, it's not because I don't think it's important, it's more because I feel like that lesson is fairly self-contained. And if you were to go back to it with the knowledge that you'll take away from this afternoon, you won't have any trouble kind of going through that episode and understanding what's going on. So I'm going to try to focus my time with you on teaching you those episodes that are a bit trickier, perhaps. Now, in terms of setup, so if you want to follow along on your local computer after the workshop is done, then you will need to go through and download the Python Novice Gapminder data and walk through the setup instructions, which will explain how to install Anaconda or Miniconda and on your different various operating systems and where to download the data. We don't have to do any of that today. And in fact, if you're quite happy to work in the cloud, then you can come back and use these cloud resources as often as you wish. These cloud resources, the public BinderHub is always available 24 hours a day, 7 days a week. So if you want to come back and use these the cloud resources to follow along, then that's great. You can do that too. In fact, that's probably what I would do, particularly as you're just getting started. Okay. So without further ado, let's just go ahead and get started. So we're going to start with running and quitting. So in this episode, I'm going to talk about Python programs. We are going to talk primarily about JupyterLab and how to use JupyterLab and how to use, how to start notebooks and how to start Python scripts and things like this. And so you're going to see how to do all those things. and how to navigate around in JupyterLab. Okay. So JupyterLab is what we have running in the browser over here. So it is a browser-based kind of integrated development environment that is the most widely, one of the most widely used tools for interacting with and doing Python development. So the JupyterLab is something that you install via Conda. And in fact, if you remember from last week, we had Conda environment files and talked about how to build environments from these files using Conda. Inside the environment.yaml is where you would list the particular version of JupyterLab that you wish to use. And so in fact, you can see I've just listed JupyterLab here, as well as all the other dependencies that we're going to make use of today. And this also demonstrates in JupyterLab, you can open files. So if you click on files, they will open here. You could edit them. If you wish, you could go in here and add more dependencies if you wish. So you can use JupyterLab as a text editor. And it has some nice syntax highlighting. So JupyterLab understands Python scripts, YAML files, Markdown files, plain text files, all kinds of different text files, and provides kind of a nice experience similar to what you might have from your standard various text editors. Okay. So there's some discussion here about starting JupyterLab. We don't have to do that. JupyterLab's already running for us because this command was run on BinderHub for us behind the scenes. But if you want to start JupyterLab on your local machine, this is the section that describes how to do that. It's important to note that JupyterLab is it's a browser-based program, but it doesn't require an internet connection. So here we need an internet connection because we are running our computations are going to be running on remote servers in a cloud. But if you're running this locally, you don't need an internet connection to run JupyterLab, but it does run in the browser. So there's some screenshots on how to do that. So the JupyterLab interface, so that's kind of what I want to talk about right now, just to make everybody a bit more familiar. So at the top, you have a standard menu bar. So this is where you have your file, your edit, view, run, and so on and so forth. Your help menus. Some of these help menus will take you to links online. So to access those online help manuals, you would need an internet connection for that. You'll notice that some of these options are grayed out. That just means that those options are not relevant given the current state of our JupyterLab. We haven't opened any notebooks or text files or things, so there's nothing to save, for example. And edit, so editing is something that has a lot of the things that you'll do in Jupyter Notebooks. So when you open a Jupyter Notebook, which we'll do in a minute, all of these things will be available for you to select and whatnot. Okay. So the left sidebar. So the left sidebar is this area here. And depending on how you've configured your JupyterLab, you might have many, many, many options here, or you just might have a few. The ones that are most relevant is the file browser. So you might use the file browser quite a lot. So you can toggle the file browser on and off to kind of give yourself more space. And this is what's called the main work area. Or you can open it up and then you can use the file browser just as you would with your mouse. You can double click on a directory and navigate through the file browser in that fashion. And you can click on the little folder here. It'll take you back to kind of what you can think of as being kind of the home directory within your JupyterLab environment. If you have different JupyterLab extensions installed, then you might have some other options down here. I'm not going to talk too much about JupyterLab extensions today, except just to mention that there is a huge ecosystem of like packages that add extra functionality to JupyterLab. It's one of the main selling points of JupyterLab is that there's such a large community that's constantly improving and adding different features and extensions and things like that. Okay, we'll use a couple of these extensions in future training. So when we talk about Git next week, we'll be using the JupyterLab Git extension. And we talk about SQL the week after that, we'll be using some JupyterLab SQL extensions to write SQL code in JupyterLab. Okay. So the main work area. So the main work area is just this area here. It's where you're going to launch notebooks or consoles or a terminal window, things of this nature. So if we wanted to, for example, launch a notebook in a particular directory, we could navigate to that directory. So if we go to Introduction to Python and then go into Notebooks, we could click the Notebook button, and that would launch a Jupyter Notebook. So we'll use this Jupyter Notebook for our working area. And you can do things like rename your notebook. So if you right-click on the name of the notebook, you'll have a handy menu will pop up, and you can go down and do things like rename. And I will just call this Sandbox, because this will be my coding sandbox today. And I will post this notebook online later today. And then you hit enter, and now you've renamed, and you can see how the name has changed up here. Okay, so we've opened a notebook, but we've lost our launcher. I guess before I move on, so if you want to save, so when your Jupyter Notebook has a little dot up here, that means that you have unsaved changes. You can save this notebook by either hitting Command or Control S. And if you go to File now, you'll see all of these things are not grayed out. So now you can just click on Save Notebook, or you could use the keyboard shortcut here, which I'm using a Mac, so this says Command S or Shift Command S to save the notebook as a different name, things like this. So this is all very similar to other kinds of programs that you will have used. Okay, so I mentioned that we lost our, we opened a notebook, but we lost our launcher window, which is what this main workspace looks like. So to get that back, you can just click this, you can toggle the file browser open, and then you can click this blue button, which gives you a launcher. And then you could do things like if you wanted to launch if you wanted to create a Python script, for example, inside of a source directory, or let's just create our Python script here, for example. Then we could just click on this text file, and you'll see it opens up a text file here, and we could rename this, and I'll call this script, spell it correctly, script.py. Okay, and so now you'll notice that when I called something .py, so a little Python symbol came up here. So that's because JupyterLab is obviously Python aware. And so now if I was type Python code, which we'll learn about in a minute, but if I just did something like print hello world from inside a script, something like this, and then again I can save it with the Control or Command S. And so then this is how you might write a Python script. And so you open text files, you save them as .py files, and then you can write whatever you want for your Python script. Okay. So Jupyter Notebooks, we talked about Jupyter Notebooks already. So don't want to go too much more into that. So let's open up another launcher window, and we'll go ahead and open a console. So if you've used Python, some of you may have used Python before, you may have been used to using Python from a kind of a console environment. Those console environments are available here as well. So you can click on a console, and this will launch an IPython console. And then here you can type Python commands like print hello world. And then the command line or the box here is multi-line or multi-line editor. So you can add things like here's another line of text. And now if you want to evaluate this Python code that you've typed in here, you can hit Shift and Enter, and that Python code will be evaluated here for you interactively. So when you're working with consoles, you can do things interactively. When you're working with scripts, you tend to write like a long script, and then you would run the script. And you can actually run the script from the console. So here, the console was started within the same directory in which the script was created. So if I just do run script.py, then that executes the script as if I had typed all of the commands here. And if you had created a script somewhere else, for example, if I went over here and I created a script in this Introduction to Python source directory, so, I will save this as another script. And then in here, I will just put, print hello again from this other script. And I'll save that. And now if I go back to the console, I should be able to run the script by passing in the path to that other script. So if you remember back from our bash training, ... was a way that you reference the parent directory in which of the directory in which you're currently running. So there I'm passing this is called a relative path to the script that I want to run, and then it executes. Okay. What else? If you wanted to see what directory you're in, you can type pwd. So many of the common Linux bash commands that we learned 2 weeks ago are actually what are called IPython magic commands, and they're available and you can actually run them within IPython. Another one would be ls. Okay. Now, one of the things that you can do with JupyterLab is that you can actually arrange all of these different, well, let's get rid of that script. I want to launch one more thing, so a terminal. But I would like the terminal to be in a different directory. So here's a terminal. Terminal is what we used the last 2 weeks primarily. So you guys should be a little bit, for those of you who have come before, you should be familiar with the terminal. One of the things that you can do in JupyterLab is actually arrange these tabs. So here I have all these different tabs like in a browser, and I can go back and forth like this, and that's okay. But I might prefer to arrange my tabs in a different way. So for example, I might prefer to have a Python console here, and then JupyterLab here, and let's see, get rid of this, and eventually I will get there. Okay. There we go. So you can kind of drag these around. And so if you wanted to have a notebook up here, and maybe instead of a terminal, you prefer to have a script. So I could then open this script and then drag the script down here. And so I could have this kind of a working environment. So you can kind of configure this around to as much as you want. So if you wanted to have a notebook here, a console down here, a script over here, however you might want to work. There are other extensions that support different kinds of plotting to have plotting windows over here that will update as you run your commands, things like this. So you can kind of configure it however you want. There's a link here to the official documentation for more detailed examples. So here's a screenshot of what's called a widget, where there is a notebook for solving the Lorenz equations, and then a script that does some plotting, and then this widget allows you to toggle the different parameters of that model to see how this is called a chaotic attractor would change depending on the values of those parameters, that kind of a thing. So if you want to get a sense of how JupyterLab works, then please take a look at the official docs. Okay. What I want to do now, just take a quick 3 minutes and allow you to play around with JupyterLab a little bit. So I'll take a look. I think there might be some questions in chat, so I'll take a look at those. But just take a minute to play around with JupyterLab, see what kind of combinations of the notebooks and consoles and scripts looks good for you. And just experiment with the different features of JupyterLab. And I will set a little timer for 3 minutes to give you some time to do that. And I'll take a look at what questions we have. Okay, so there's a question from Sammy. I missed how you opened the console. So all of the, whether it's a notebook or a console or a terminal or a text file, they are all opened from the launcher menu. And depending on where you are in the file system, when you click this blue button, you get a launcher menu. So here, my file browser has me in kind of the root directory of the file system. And so when I click the blue button, I get a launcher that has no path at the top. But if I had gone into the Introduction to Python directory and clicked the launcher, I get another launcher that now is launching these things from inside the Introduction to Python directory. But everything is launched from the launcher menu. Shuk has a question. How did you submit what you wrote in the console? So that's a good question. I probably did it without even mentioning it. We'll talk about this more in a minute, but whether you're in a console or a Jupyter notebook, you submit things by shift and enter. Oh, I seem to have lost my kernel over here. So there, so you get 8. If for some reason you lost you had no kernel over here, if you just click this and select Python 3, then that's all you need to do. And similarly, if I was to launch a console, if you type 4+4 and hit shift and enter, then it will evaluate that. Okay. Someone cannot see the bin directory. So there is inside, so there's 2 bin directories. So one bin directory is for the whole repo, but then there is a separate bin directory, which I think is empty. inside the Introduction to Python directory. So if you click, at any time, if you click this folder, it should take you back to the that directory. So again, if anybody is ever needs to get the links, then the links are from the Introduction to Data Science workshop repo. So I'll put that link back into the chat just for anybody who is who needs it again. Okay. Okay. So let's move along. Okay. Okay. Sorry, I just wanted to make sure everybody is muted for background noise. There might be some background noise here. My lawn is being mowed at the moment, which is a bit unfortunate. Right, okay, so using the Jupyter Notebook for running and editing code. So we're gonna work today primarily in the Jupyter Notebook. So I'm gonna talk a little bit about the different modes of Jupyter Notebook. So when you're using Jupyter, you have different kinds of cells, and you type things into the cells, and then you use Shift and Enter to execute what is in that cell. So if we wanted to do hello world, you type the command print by the string you want, and the string you want to print, and you hit Shift and Enter, and then that executes that command, and then returns that to you in the output cell. And you can toggle output cells by clicking this little blue box over here. Similarly, you can hide input cells by clicking this little box here. We all back? Not quite sure what happened there, but my Zoom meeting just died on me. But it came back, and we're still recording, so that's positive. So let me share my screen and I guess we'll just pretend like that didn't happen, and hope that it doesn't happen again. So the notebook has two modes, command mode and edit mode. So when you're in edit mode, you're actually editing a cell. So you're typing things like some mathematical equations or simple arithmetic, things like this. And you hit Shift Enter and you evaluate it. Now, when you're in command, so edit mode is indicated by this blue box. So when your cell has got this blue box around it, it means you're in edit mode. Yeah. Now, when you're in command mode, you can toggle to command mode by hitting Escape. And notice that this blue bar over here, which indicates kind of where you are in the notebook, is still there, but that blue box is gone. So if I click in here again, I go to edit mode and I get my blue box back. If I hit escape, then I'm in command mode and there's no blue box. So I'll just put a comment in here that says, here is a cell. Okay, now I'm typing things in edit mode. If I hit escape, and then you can use keys, different kind of shortcut keys to do things like create a cell above the previous cell by pressing A. Or if I went back to the cell and I hit escape to go to command mode and hit B, I would create a new cell below that current cell. So if I went in here and said, here is a cell that I want to remove. So if I wanted to remove this cell, then I would hit escape to go to command mode and then X, and that would delete the cell. And if I wanted to undo that, because actually I really didn't want to delete that cell, I can just hit escape to make sure I'm in command mode and hit Z, and that undoes the deletion. Yeah. So there's a whole bunch of these shortcut keys. If you go to the help menu, there is different help menus in here, the Jupyter reference, things like that, that will tell you about some of these shortcut keys. There's some more information in the notes over here about different shortcut keys and things like that. So in addition to code cells, so if I hit escape and then below, I'll create a new cell. And then in addition to code cells, JupyterLab has markdown cells. So markdown is how you can intersperse code and documentation. So if I wanted to make this a markdown cell, I can either go up here where it says code and change it to markdown. And then if I am in here, I can type things like here is a header in markdown. And if I hit shift and enter, then this gives me a markdown cell that has, you know, a header in it. And you can do all kinds of stuff in markdown. So let's say I wanted to create a new markdown cell below this. So I can, again, either go up here and go to code markdown, or in command mode, I can hit, or in edit mode, I can hit escape to go to command mode and hit M, and then that converts this to a markdown. So this is another markdown cell. Here's some regular text. You can make bulleted lists or numbered lists. I have 1, I have 2, etc. And if you hit shift and enter, then that evaluates that. So that you can also do unordered lists. So if I double click on the cell, I can go in and edit it again. So you can also make unordered lists with asterisks. So 1, 2, 3, like this. You can do sublists. If you wanted to have a subheading, you do 2 of the hash symbols. So this is a subheading. And you do 3 of them. This is a subheading, and etc. So you can kind of make this out as format it however you want, subject to the constraints of Markdown. And actually, Markdown allows you to put, not entirely, allows you to put HTML, embed HTML within Markdown cells as well. So if you know HTML, you can customize some HTML code in here, and it would also render as expected. You can add links, images, all kinds of stuff. So there's some exercises here, but in the interest of time, I actually want to, well, actually, no, I'll give you 3 minutes to take a look at these exercises. So the exercises, there's some stuff on Markdown, but then just get some practice of switching between command mode and edit mode. Write some simple arithmetic expressions, use Python like a calculator, and evaluate the expressions. Get used to the shift enter mode of evaluating expressions, and things like that. I guess one other thing I'll show you is this last section here. So you can embed math equations. So you can embed math equations using LaTeX. And if you want to have a math equation, you can, that is center aligned, you can put 2 $ around it and then write something like e to the minus I +1 equals 0, I think. Here is, I think this is Euler's formula. So I'll also show you how to embed a link. So if you go over here and type Euler's formula, you can go to Wikipedia, and it's e to the I pi. I pi, yes. So we'll copy this link and go back to our Jupyter Notebook. E to the I pi. It's funny how I only partially remember this formula. Yeah, there it is, +1 equals 0. Euler's identity. So that's an example of both typesetting maths as well as embedded a link. And actually, you can type, if you know LaTeX and you're used to using things like align blocks and equation blocks and all this other stuff with formatting maths, you can pretty much type quite arbitrary, mathematical LaTeX into these markdown cells, and they will render as expected. If you really want to get into it, you can actually customize your Jupyter Notebook so that they will allow you to typeset kind of whatever you want with respect to LaTeX in them as well. So, okay, let me set my timer for the exercises. So if you want, and just take a look at these other exercises for our next few minutes, have a play around with using Python as a calculator, that kind of thing. And I will check the chat for questions. So Fatima has a question about upgrading Google Colab to Colab Pro. I honestly don't know the answer to that question. I would assume so. I would assume that you should be able to do that here in Saudi Arabia without any trouble, but I don't know. Any questions about kind of the basic mechanics of using Jupyter Notebooks or opening Python scripts, Python consoles, things like this? So Sama says the interface resembles a MATLAB interface. So yes, so actually the origin, I don't know, myth, legend of Jupyter Notebooks was that they were created to mimic Mathematica notebooks, actually, because the original creators, Fernando Perez and Brian Granger and others who started the IPython project, from which all of Jupyter kind of emerged, was they were physicists who were in grad school who were wanted to have kind of an open source alternative to Mathematica for doing their work. And so since then, there's been a lot of kind of, how I saw it, cross-pollination in terms of interface design. So Jupyter Notebooks have been incredibly influential, not only on the open source community, but also on the proprietary notebook interfaces. So all of the major cloud providers have notebook interfaces that are built on top of Jupyter Lab. Google's Colab, for example, is a port of Jupyter Lab that extends it with some extra features that they have not contributed back to the community. But Amazon has one, Azure has one, MATLAB and Mathematica have adopted a lot of the features of Jupyter Notebooks because they've become so popular. So Hassam has a question: can Jupyter Notebook be installed and run without internet on Ubuntu? Absolutely. So, well, so To install the software, you're going to need an internet connection because you'll need to download all the packages and things like that and build your conda environment like we talked about last week. But once you've downloaded the packages and built your conda environment that includes JupyterLab, when you launch the JupyterLab server, as discussed at the very beginning of this episode here, when you activate your environment and you type Jupyter space lab and hit enter, that is going to run JupyterLab in a browser on your computer. It's not going to require an internet connection. It's just using the browser because web browsers are so ubiquitous now that everyone is used to working with them. And so it's a very comfortable environment for most people. Okay. How can we, so there's a question about how can we switch a markdown cell to a normal cell? Good question. So I covered how to go. So there are two ways that you can do that. So this is a normal or code cell. And I can hit Shift and Enter and evaluate that, but it doesn't do anything. So if I wanted to turn this into a markdown cell, I could either go up here and do markdown, and that turns it into a markdown cell. Now, if I wanted to convert this back to a code cell, I could either go up here and change this back to code, and that changes it to a code cell, or I could, let's do escape and M to change that to a markdown cell. I could hit escape and C, I think. And M. And now I've forgotten. You can tell that I go from code cells to markdown cells quite a lot, but not often the other way. I've forgotten the keyboard shortcuts. So nope. Well, I've forgotten the keyboard shortcut for how to switch back from markdown to code, but you can definitely do it by using this toggle menu here. Okay. Right. So let's see what's going on in chat before we move on to the next episode. Oh, thank you, Mohammed. Mohammed says it's Y. So let's see. So escape M is markdown, and then escape Y is code cell. So it's Y. Thank you. And there's probably a very good reason for that. So if you want to switch from a code cell to a markdown cell with the keyboard shortcuts, again, you can do escape and M. And then to go back from a markdown cell to a code cell, you can do escape and Y. There you go. Okay. Let us move on to the next, the next episode. Okay, so variables and assignment. So we're going to quickly move through variables and assignment. So I will just, now that I will start using variables and assignment. Okay. So we're going to talk about how you store data in your programs, and we're going to see how to assign scalar values to variables and perform calculations and things like this. So the basic idea is that you can create a variable by, say like age, and you can assign a value to it, say 42. And if you hit enter, you can, again, text, or these code cells are multi-line, so you can make, you have multiple lines of Python code in a cell. So you can do first name, Ahmed. And so these are two variables. The variables are on the left-hand side, age and first name. The values you're assigned to them on the right-hand side, 42, and the integer 42 and the string Ahmed. Okay. So you can use these variables that you've created across cells. So I defined these variables here, but if I have another cell and I do something like first name is age years old. So I can reference these variables in other cells. Yeah, and so Python basically substitutes the value for this variable and the value Ahmed for this variable and the value 42 for this variable, and substitutes them in, and then runs this print function and prints the result. Okay. Variables have to be defined before you can use them. So if I try to do something like this, try to print this variable last name, then you'll get this red underscore under there. And if you put your cursor there, it tells you that, oh, this is an undefined name. So that's telling you that there's going to be an issue with this code. But if you were to try to evaluate this code, you get an error. And that basically says this variable has not been defined. So we haven't given last name a value. So if we were to go up here and then write last name equals Smith, and then evaluate this code, now it will evaluate because we've given a value to this last name variable. Okay. So you can use variables in calculation. So if we wanted to increment the value of age by 3, we could set age equal to age plus 3, and then print Ahmed has grown. His new age is age. And so we have added 3 to the value of age and then reassigned that value to the same variable and then use that variable as an argument in the print function. Okay. What else? So you can, if you have a string, so this is our first kind of discussion of slicing and accessing in Python. So if you have a string like, it's another atom besides helium, so radon, and then you want to get the first letter in that string, then you can use square brackets and then 0. So Python is 0 indexed, much like MATLAB, I think. R is indexing starts at 1, but Python indexing starts at 0. That's very important. So if we do the atom name with square brackets and 0, that's going to pull out the first letter in this string, basically. And strings can be what are called sliced in Python, or subset. So if you wanted to get the first 3 letters in atom name, then you could go from 0 and a colon. And then the way it works, it goes start up to, but not including the stop. So if we want to get the first 3 letters, that's the 0th, 1st, and 2nd letter, we need to go 0 up to, but not including 3. And that gives you rad. Okay. There's some other built-in functions like length to get the length of things. So if we want to get the length of the atom name, then you can do that. Use meaningful variable names. Don't avoid using like writing code that is like mathematical notation where you use like X, Y, and Z as variable names. Like use sensible variable names, sorry, sensible is a bad word. So use, that's not what I meant. So use variable names that have context within the program that you're writing. So, there's an exercise here about a calculation involving converting time. So this total seconds is equal to minutes times 60 plus seconds is much better than TS equals N times 60 plus S. So this last way of choosing a name provides you a lot more context about what that calculation is representing. Whereas in this M and S could be anything. It's not necessarily obvious what they are. Okay, so take a few minutes. I'll set timer for 5 minutes. This also would be a good time if anybody needs a bio break to just take a quick break, and we'll come back in 5 minutes, and I'll pick up with the next episode. So just have a look through these exercises and see how you get on, and then I'll be back in a couple of minutes. So I'm just going to stop sharing for a moment, and I'll also pause the recording. Okay, I'm back. That short break. So still about 3 minutes left for the exercises, for those of you who are working through the exercises. I'm just going to take a look in the chat. So yes, again, so just as a reminder for people who might be joining later, the session is being recorded and it will be made available tomorrow via our YouTube channel. You'll get a link to the YouTube channel from via email, probably also tomorrow after I've posted the link. So I know I might be going a little bit quickly. It's because I want to cover as much material as possible, so you can ask me as many questions as possible whilst I'm here. And then if you do need to review the session, it will be available on YouTube. Any other questions while we're just kind of working through these exercises?
May I ask a question rather than writing it?
Yes, please, please.
Yeah, so what if we use negative indices rather than using positive? So
that is a great question.
For example, like -1 to -2, how it will access the array?
Okay. Best thing to do is to try it out and see. So Python supports negative indexing. So for example, if you want to access the last character in this string, or as we'll see later when we work with lists and things like that, and arrays, the last element in a list or an array, then you can access it using -1. So that pulls out the end. Now you can do negative indexing and go backwards by if you were to do -3 to -1. Okay. So now remember how slicing works. So it includes the start, but not up to, but not including the stop. So if you start with -1 here, then -2 is O, -3 is D. So that's why you get the D. And then it goes from -3 to -2 to -1, but not including -1. So then you get the DO. If you wanted to go from, say like the last three letters in the string, you could do -3 and then just a colon and leave it blank. And that will go from -3 all the way to the end. And actually, similarly, you can do that from the front as well. If you want to go from the beginning up to, the third letter, say, you can just leave off the beginning and it kind of fills in the 0 here. Okay, does that answer your question, Muna? Okay, I will assume that answered your question. Okay, cool. So my timer just went off. So unless there are any more questions about any of these exercises, I would like to move on. The solutions to these exercises, you can get them by clicking on this little down arrow. So if you feel like there's an exercise that you don't quite understand, but you're a bit too shy to ask a question about, then you can just click the solution to find out what the correct answer is. Right. Just quick. Okay, great. Moving along. Okay, data types and data conversion. So this is actually an episode that I'm going to skip. So it talks about integers, floats, and strings. I'll introduce those as we start using them in the following episodes. And it goes into some detail about the different types and how type controls the operations that you can perform on values. So, you can add two integers or two floats together. You can add strings, but it acts like string concatenation and things like this. So I'm going to leave this as kind of an episode as homework for you guys, but I'm not going to cover it in detail here. Okay, built-in functions and help. So this one I do want to cover. So built-in functions and help. It's short, but it's important for you to know how to get help. Okay. So comments. So I guess one of the things that I want, so this episode is about showing you how to access some basic built-in functions like print and len and some others that we are going to introduce, and how to find out what they do. So basically about accessing various help menus, okay? So some of the way that you might actually help yourself in the future is by leaving comments about your code. So, and documenting kind of what your code does. So the hash symbol is, so this is a comment and will be ignored by the Python interpreter. And then, so this is an inline comment and will also be ignored. Yeah. So there's two ways that you can do comments. You can kind of do comments like as a block, or you can put them kind of inline and they'll just be ignored. Okay. So functions can take 0 or more arguments. So some functions that that we've seen so far would be so print. So print, this is an argument to the print function. Print also takes no arguments and also takes more than one argument. I can even use a comment. So takes 0 arguments. So print without any arguments just prints a blank line. And print with more than one argument kind of concatenates them together into a single string, but adds spaces in between. Okay. You might wonder, well, how can I find out how that print behaves that way? And we'll see this in a minute, but if you put a question mark after print and evaluate that cell, it gives you what's called the doc string, which is the basic documentation about the function and how it works, including what the what's called the function signature, which is this part here, and then a description of what the function does, followed by a description of the different inputs to the function. And it tells you here that the default separator is a space. So if we were to pass in the separator argument and define the separator as a, I don't know what would be kind of silly. So as a dollar sign, then we get that behavior. Okay. So all functions return something, even something like print, which seems like print seems like it both returns something, but maybe it doesn't return something. So print has what's called a side effect in that it takes in arguments and then prints output to what's called the standard out. And in Python or in Jupyter notebooks, the standard out is basically what shows up in these output cells here. Yeah. But every argument returns something. So, or every function, sorry, returns something. So if you do print, even without, so this returns something, even if you pass no arguments. And you might say, well, what is this result? So here on the right-hand side, we call this print function, which returns a value, which then gets assigned to this variable result. So when we try to execute this, we don't get an error. It executes without an error, but it doesn't seem to return anything. So there's a function that was talked about in the called type. And if you look at type, type basically just returns the type of a variable or an object. And so if we ask for the type of result, it's a none type, which is just the special type that is returned by functions that don't return a regular type. So all functions return a type, might be the none type in something like, in case of something like the print function, but all functions return something. So there's other functions like min, max, and round. So you could take the max of a bunch of integers, and you can see here that actually some help menus are kind of toggling and popping up as I start to use these functions. So that's another way that you can get help. So that gives you 9. If we were to the min of this, that would give you 1. Min and max work on not just numbers, but if you were to put anything that can be ordered, so like letters can be ordered alphabetically. So if you were to put characters in here, you would get an answer from min or max. So any type that can be ordered, you can pass into the max or min functions, things like this. So functions might work for only certain combinations of arguments. So if you were to try to do the max of 1 and the letter A, then you're going to get a type error, because even though you can take, like, say, the max of 1 and 2, or the max of A and Z, Python doesn't know how to compare an integer with a string. It can compare integers with integers and strings with strings, but it can't compare integers and strings. There's no obvious way that result should return. So if you wanted to get this to work, you would have to do something like either use the string function to convert this integer to a string so that they can be compared, or use the integer function to convert the string to an integer, which, well, actually this won't work. But if this was a 3, then you could do that. So again, the takeaways are more just getting you familiar with using some built-in functions, the syntax of functions and arguments, and just this idea that sometimes some functions have certain kinds of arguments that they'll accept, and sometimes they have other kinds of arguments that they won't accept. Right. Let me check the chat. There's some questions in here, I think. So yeah, so I mentioned there's a couple ways to, I mentioned one way to get help. So if you wanted to know how this max function behaves, if you use the question mark and shift and enter, you'll get the doc string as an output. But you can also do max, and then if you just put the parentheses, then you'll get this pop-up menu, which explains kind of what's going on with the different arguments and things like that. And the doc is basically displaying the doc string, but in this little pop-up dialog. And as soon as you start typing, moving your cursor, it will go away. And if you want to manually make that pop-up menu come up, you can put your cursor in between the parentheses and then hit Shift and Tab, and that will bring up the doc string as well. So that's another way. So this is okay, but then notice as soon as you start typing something, it goes away. So if I do Shift and Tab, and then I was like, okay, right, so I want to read this doc string as I'm typing out these arguments to make sure that I get the arguments correct. As soon as you start typing, it goes away. So what I will often do is if I have a complicated function that I'm trying to get right, I will hit escape and above, or escape and A to create an empty cell above. And then I'll do like this. I'll put the function that I'm writing and a question mark, and then evaluate the doc string. And so now this doc string is here. And so now I can go in here and I can say, okay, well, I can either put something called an iterable, which could be like a list or an array or anything you can kind of iterate over, or I can put a bunch of arguments separated by commas. And so I'll put a bunch of things separated by commas, and that looks okay. And then, okay, right, now I've got an answer, my function is behaving properly. And then if I want to clean up my notebook, I could go back and hit escape and X and delete that cell. Something like this is how I might work. And I'll just do escape and Z to undelete that cell. Okay. So functions attached to something called objects are called methods. So let's give an example of that. So if you wanted to have some string, so we have this sum string, and if you use the type of this sum string, you'll get an error because you've made a typo. Then you know that it's a string. So the type is string. The variable sum string is an example of an object of type string. And so string objects have certain kinds of functions that will operate on them. And when you have a function that is operating on an object, it's just called a method. So if you put a dot and then hit tab, then you can get all of the methods or the functions that operate on the object of type string. And you can kind of go through here and find all of these and look at all of them. And notice that you're getting kind of the doc string over on the right-hand side. So let's let's look at swap case. So when you're calling a function with that is a method that you're accessing using this dot notation, then you usually have open and close parentheses, and if there takes arguments, you might put some arguments in here, but this takes no arguments, which we can see by looking at the signature, takes no arguments. So this is going to convert uppercase characters with lowercase characters and vice versa. So then we get a string that looks like this. Okay. So there are other ways to get help. So there's a built-in function actually called help, which you can call, you can pass a function as an argument to the help function and get the doc string that way, or maybe some more help that way. I tend to not use that really much at all. I use either the question mark, or I would use the shift and tab approach. Right. Okay. Okay, so there are two kinds of errors. So one error is called a syntax error. So syntax errors are when basically the Python can't understand what you're trying to do. It doesn't understand the program that you've written. So, you know, Python has a particular syntax that you're trying to learn today about how to write valid Python programs. And if you've written invalid Python, then the Python interpreter is very strict. It only understands Python. So if you've written something in Python that's not quite right, and it's not valid syntactically in Python, then the Python interpreter will just say, oh, I don't know how to understand this, and it'll throw a syntax error. So examples of syntax errors are, you know, there's some here in the teaching notes. So there's an example of a syntax error that you get if you forget to close your parenthesis, or not your parenthesis, your quotes, single quotes or double quotes. White space in between an assignment. So, so this could either be two kinds of syntax errors. So it could be you've got an extra equal sign in here because you were actually trying to just assign age the new value of 52. Or that could have been a typo in that you were actually trying to do a test of whether the value assigned to the age variable is 52, in which case you might have had an extra white space. Forgetting to close your parentheses or brackets used to be a favorite kind of syntax error, but that tends to not happen so much anymore because, as you'll notice, Python tends to auto-complete brackets for you. So, you know, I can just keep doing this, and it's going to be very hard, even if I make a bunch of nested brackets, it's auto-completing the brackets for you. And so it's very hard to make that kind of an error. Although this will give you a different syntax error in that it will print, it will try to print an empty, a print with no arguments, but then it doesn't, this syntax doesn't make sense. So it just throws an error at the first square bracket. So it's a different kind of a syntax error. But you could see that it auto-completed all of your various kinds of brackets. So you're very unlikely to make this kind of syntax error. Okay, the other kind of error is a runtime error. So runtime errors are a bit more nefarious in that you know, runtime errors can crop up, you know, hours into a calculation or days into a calculation if you're doing something that's really long running. So this would be valid, syntactically valid Python code. So this is syntactically valid, but it will throw a runtime error. And the reason is that obviously this is just a typo, but Python doesn't know that this is a typo. It just assumes that there's going to be some variable called AEG that is defined somewhere else in your program. So from a syntax perspective, this is perfectly acceptable. It generates a runtime error, though. And so to fix that, obviously, in this case, we would want to do that. Okay. So take a couple of minutes and have a look at these exercises at the end of this episode and see how you get on. This one is usually causes several people to trip up. So I'd have you, if you just want to look at one particular exercise, check out Spot the Difference, see how you get on with that one. I'll set my timer, and then I'll see if anyone has questions in the chat. So I'm just going to briefly stop sharing. Okay. So for the next 3 minutes, you're going to have a look at some of those exercises, and then ask any questions you want in the chat or otherwise, and then we'll move on. Any questions? Since you guys are so quiet, you must be working through your exercises very studiously. Okay, so just a little bit left to, a little bit of time left to work on those exercises. Okay, so I'll share my screen again. So I'm going to go through this one exercise, Spot the Difference, and then we'll move on, just to kind of make sure that, so this is the Spot the Difference exercise. Okay, so we have an easy string, which we call ABC. And then we want to print the max value of the easy string. So we would guess that this easy string, the max value is going to be C. Indeed. So, but then we're going to have a couple other strings. So rich, gold, and poor is 10. And then we want to print the max of rich and poor. Okay. Now, the question is, what is this going to print? And the answer is 10. And you might think, well, why? What is happening here? So what happens is that, so the max function is going to compare the values assigned to the variables rich and poor. So what will happen is that, if I go down here, so first, the string that is assigned to the variable rich will be substituted in here for the rich variable, and then the string that is assigned to the variable poor will be substituted in here. And so max will compare the string GOLD with the string TIN, and it will start by comparing the characters in these strings. That's how you compare strings. You kind of line them up and you compare them letter by letter. And so since T is greater than G, then 10 must be greater than gold, and therefore 10 is what gets printed. Now, what will happen if we change the T to a G? So compare gold and gin, which of these is going to be greater? So this time it's going to compare the G and the G, so that's the same. So then it's going to move on to the second letter and compare the O and the I. So this ought to print gold, because O is greater in the sense that it comes after in an alphabetical ordering the letter I. Okay. Okay, so moving on to the next episode. Morning coffee. So this would normally be the mid-morning break in a full day workshop. So we're going to move right by that and talk about libraries. So I will add libraries. Okay. So using libraries is really important, in part because there's the Python language, and then there is the Python standard libraries, which include libraries that are prepackaged with Python, and then there's a huge community of libraries in the Python ecosystem, which is what makes Python such a popular programming language. So Salma is saying that you can't seem to find the binder page you are looking for. If by that you mean these links here, so the Chaos BinderHub and the public BinderHub, so I will copy that and post it into the chat. So if that is what you're looking for. Okay. Hopefully that will sort you out. Okay, so if you want to use libraries, you need to import them before you can use them. So for example, if we want to use the math library, we need to import the math library. And once we've imported it, then we can use it. So we can import it, and then we can say py and then math dot py. And you can see the help menus are kind of toggling, and so we can see that this is going to convert a string or a number to, or wait, that's pi, there we go. And so that gives you PyViz 3.14159, et cetera, et cetera. You can also access, I'll just leave off the print statement. So if you want, so if you're wondering why you can leave off the print statements and then, like here, I don't have a print statement here, but it prints out 47 as the output. That's something that happens in notebooks or IPython consoles. But if you want a value to be printed out when you run a script, then you need to use the print function. But here in notebooks and in consoles, you can get by without it. So you can look at what is the math. So if we were to use the cosine function of math.pi, and if you remember your trigonometry, so pi is 180 degrees, and cosine is kind of the x-axis, and sine is the y-axis. So cosine of pi should be -1. And then math.sine should be math.pi should be 0. And that's as close to 0 as you can get given the numerical precision of the computer that you're on. And then if we wanted to do other things, we could compare, so for example, math.tangent of math.pi and math. Now I'm really having to dig back to my trigonometry divided by math cosine of math pi and so two different ways of calculating the tangent, and we arrive at the same answer. That's good. So you can pass libraries into the help module. I almost never do this. And this just basically gives you the help menu. I typically use this kind of dot notation. So I type math dot, and then this allows me to have access to basically all of the information that's in that help string. But I can just kind of toggle through here and find whatever it is I'm looking for, basically. And of course, if I know that it starts with an F, I can type F, and then this will limit me to only the things that have an F and then that kind of stuff. Okay. Typing math.this and math.that is a bit annoying. So if you know that you're only going to use certain functions from a package, then you can do from math import the things that you're actually going to use. So cosine or pi. So cosine, pi, sine, tangent, for example. And then I could do the cosine of pi. I could write this same expression here much more succinctly as the tangent of pi and the cosine, the sine of pi over the cosine of pi. And
David, excuse me.
Yes.
For the command line number 53, we know that sine pi equals 0.
Yes.
Although here the number shows very, very small number, yes, but it should be exactly 0. So
Right. So this math library is not a symbolic math library. So there is a symbolic math library called SymPy. I don't think I installed it in this environment. Yeah. So I did not install. So this is the error that you would get if you try to import a module that you haven't installed. But there is a symbolic math library called SymPy. And it's really, really awesome. It does a whole lot of, it basically is like a lot of what Mathematica does. Not everything that Mathematica does, or Maple or other symbolic mathematics libraries, but it does a lot of the basic stuff, like symbolic derivatives and integrals and things like this. So there they have ways of doing kind of exact calculations where things are exact. But in this case, we're using a mathematical or numerical implementations of these functions. And so the precision with which you can represent things like 0 is limited by the precision of the computer, of the floating point arithmetic on which your computer is happening. So that's why you're getting these numbers here. And interestingly, even note here that, so here we have a representation of 0 that is very, very close to 0, but still positive, technically. And here, so the tangent of pi is also 0, yeah? But here you have something that is very, very, very close to pi, or very, very close to 0, but actually negative. So, you know, the usual caveats with numerical precision and doing, you know, numerical computation on a computer definitely apply when you're doing, when you're using Python. So,
I didn't care about tan because the error will be compounded, as you know, tan sine over cosine. So of the basic, I mean, if sine pi is not 0, then definitely tan will be not accurate.
Yeah. Okay, so where was I? Right. Okay, but typically, you, although you can do these kinds of import statements, you don't. You typically don't, and the reason is that let's suppose that you had something already defined, like a variable or a function that you had written that was called cosine or sine or tangent. Then when you import specific things like this, it would overwrite. It would overwrite those things that were already available in memory. And so what I mean by that was, suppose that you did. Okay, suppose that I had gone up here and I had said tan, and I had called it a string is a color. And okay, so now here I have tangent, or I have tan, which is a variable that I've defined, which is assigned the value string as a color. If I now come down here and import something with the same name, a function, now I get the function result. So this tan as a variable is gone. And so now if I do tan, it tells me that this is a function from the math library. So it's overwritten this variable here. And so this is called clobbering. And this can happen quite frequently when you import specific items from packages. This example is a bit contrived, but it can definitely happen. So what I would recommend, and what you often see in Python code in the wild that you might encounter from a Google search, or if you look through GitHub and various open source libraries, is importing with an alias. So instead of math, you might say import math as m, for example. And then we can use m dot cosine of m dot pi and get -1, or m dot sine of m dot pi, yeah, things like this. So this is typically how I will import things. Okay. So there are some exercises here. So let's take, just take a couple of minutes. So I'll set the timer for 3 minutes. Maybe have a look at this jigsaw puzzle. It's an example of something that's called a Parsons problem. So you've got some code that's almost complete, but not quite, and it's a bit scrambled in that the rows are out of order. So see if you can rearrange the rows of code here and then fill in the blanks to print out the result, which in this case will be randomly selecting a character from this string. And we'll go over that. We'll go over that together. Okay. So Muna asks, so how to add SymPy to the environment? So that's a good question, Muna. One of the things that you could do is you could use something called, let's see if this is in here. So there's an IPython magic command. Let me check if this works first. So there's an IPython magic command for conda and pip, which you can use to install things. So if I wanted to install SymPy into the environment in which this notebook is running, so that's what's meant by the current kernel, then I should be able to do this. And then this, of course, is going to go through the whole conda routine. So it's going to have to check and make sure that there's no issues with dependencies. And for some reason, it's noted some potential problems, but I think we can ignore those. And then it's downloading and installing SymPy, plus some other stuff that SymPy needs. Now, let's see if I can import SymPy. Yeah, so now I can import SymPy. And so inside of SymPy, there are, I have to wait for a minute for my my tab completion to catch up. But I think, or maybe I would import SymPy as SP. That's usually how I would import SymPy. And then I think SymPy has its own representation of pi and its own cosine function. Yeah, so we can do cosine of SymPy.pi. And then if we wanted to do cosine of sine of pi, now we get exactly 0. Yeah. Now, the other way that you would add normally I wouldn't do, this is kind of, I'll put a little comment here. So only do this when you are prototyping. Okay, it's much better to put this in, what I mean by prototyping is you're just kind of like playing around, trying to hack something together, kind of like what we're doing here. We're playing around, we're learning. If this was a production environment for like a project that I had, what I would do is I would probably stop the notebook, shut down JupyterLab, go back and add SymPy in here as a dependency, and then rebuild the environment and then relaunch JupyterLab. Yeah. That way, because if I don't do that, then I have a habit of forgetting something. Like if I install a bunch of stuff inside my my notebooks, then I have a habit of kind of forgetting what I've actually installed. And then if I was to go back and create this environment and I hadn't remembered to put these dependencies in here, then I would get an inconsistent environment again. Like I would lose the fact that I had installed these things in the notebook. So I tend to update here. Right, okay. Cool, so let's, that was a great question. Let's see if we have 2 more questions.
So what is the use of the notebook? I mean, who will use the notebook usually for programming or something like that?
So the notebooks are incredibly popular, and they're used for everything from kind of an interactive lab notebook. So that's what most of our users here at Calston and most of the places that I have worked as doing machine learning or data science, notebooks are the way that we kind of record what we're doing in a way that we can share it easily with others. That's the key use case for the notebook. If you are developing kind of production, like machine learning pipelines, like if I'm going to run a Python job on IBEX that's going to run for quite a long time, maybe doing deep learning training or some other machine learning kind of model with scikit-learn, then I'm going to write that in a Python script, because a Python script can be launched as a batch job. I can just launch it on a cluster or on a cloud server and let it run until it's finished. Whereas an interactive notebook is interactive. So you launch a notebook server and we're here doing things interactively. So it's a kind of an environment for playing around, for experimenting, for sharing your work with others. But if you are going to, write some, I'll call it production code that is going to run repeatedly on remote servers and needs to be, optimized for that use case, then you want to write that in a script. So how to use it on HPC. So that's a great question. It's a little bit out of scope for today. On our YouTube channel, I will be putting some videos on how to launch Jupyter notebooks on our HPC infrastructure here at KAUST, on IBEX and on possibly on Shaheen. So you can do that, but it's kind of not really the way that those environments are designed to work, where they're more focused on batch jobs and writing scripts and launching scripts, but you can do it. Okay. Okay, good questions. So I just want to do this quickly, this Parsons problem, because it's a good, so I'm just going to kind of copy it. And so this is the jigsaw puzzle exercise. Okay, so basically we want to rearrange this and get some working code out of it. So the first thing that we want to do is move the import statements to the top. So usually you're going to put your import statements at the very top of your script, or maybe of your notebook. It's quite common, for example, for all of the import statements for packages or libraries used in a notebook to be at the very top of the notebook in the first cell. That's kind of a convention, but you can obviously put them anywhere. And so then we're going to define this variable basis, and then I'm just going to comment out the rest of this stuff. Okay, so that works. Okay, so now we've defined our basis variable, and then what we want to do is randomly select a base from this string. So we need to do that, we need to maybe randomly generate some integers between 0, which would select A, and the length of this string, which would then select out the last character here, basically. So we can do that. There is a random package. So if we were to look at random and then rand range, and maybe shift and tab. So random, so choose a random item from a range, stop or start to stop, and does not include the endpoint. So this behaves just like the kind of slicing that we want. So we can do a range from 0 up to but not including something. And actually here we're supposed to call this thing n basis. So n bases is probably short for the number of bases. So we can get rid of that. Now, n bases, we know we need to define it before we use it. And we can actually get the number of bases by just assigning that to be the length of our bases string. And then we need to assign the output of the random range to some variable. I'll call that random index. And then here we can replace this with random index and this with random index. Okay. And that extra space there is not needed. So if we keep running this, so now we are going to continually randomly choose an integer and therefore choose a base. You might wonder, well, what if I didn't want it to be truly random? What if I want it to be random, but I wanted to start it from a particular seed? Well, there's probably in the random library some kind of function for setting a seed. Random.set. There it is, random.seed. And initialize internal state from a seed. And so you can put an integer in here. So I will put 42. And now that I'm setting this seed, I'm going to get the answer the same answer every time. And if we were to comment this out, we'll go back to getting different random bases. Okay. All right. Any questions before I move on to the next episode? Okay. All right. So now we're going to do some data analysis. So we've talked about libraries, and now we're going to talk about a library for doing data analysis, and that's Pandas. And I'll just go over here and Pandas Python. It's always good to put Pandas in Python rather than just Pandas, because otherwise you'll end up with the animals as opposed to the Python library. So here's the web page for the Pandas library. There's a great book by the creator of the Pandas library, Wes McKinney, called Python for Data Analysis. It's in its second edition. You can get a PDF, a free version of the PDF here. Highly recommend it to do a deep dive into the functionality for Pandas, which is the key the data analysis library when you're getting started with doing machine learning and data analysis in Python. So highly recommend it. That was how I learned Pandas, was actually going through the first edition of his book. So we are going to so I'm just going to put a markdown cell reading tabular data into data frames. Okay, so we're going to import Pandas as PD. So this is the typical alias that you'll see for Pandas, is we're imported as PD. So we're going to see how to import the Pandas library, how to use Pandas to load a simple CSV data set and play around with it. Okay. Now, one of the most important things about reading in your data is knowing where your data lives. So my Sandbox notebook was created inside the Introduction to Python notebooks directory. So here you can see the Sandbox notebook. In the Introduction to Python directory, there is a data directory, which has all the CSV files. So when we go to load our data using this read CSV file or function, we need to provide the path from the current directory where the notebook is running which is this notebooks directory, to the CSV file we want to load. Yeah. So fortunately, we'll get some help with that. So we need to go up one directory from notebooks to introduction to Python, down into the data directory, and then in the data directory, we have all of our files here. And I'll just expand this just for a minute so you can see what the file names are. I guess I need to do this. Okay. So here are all the files here, and we want to load the Gapminder GDP Oceana. And we'll store this in a variable called df for data frame. Oh, file not found. Why is that? I must have a typo somewhere. And oh, let's see, where am I? Notebooks. So up into data, Gapminder. Aha, I do have a typo. I left off the extension. There we go. So you can run, just like in an IPython console, you can run this pwd command, which is actually a Unix command, and it will tell you where you are. So again, this is just me checking that I wasn't somewhere else. And then you can pass in the path from where you are to where your CSV file is, and then you can load your data. And now we have our data frame. So this data has only 2 rows and a whole bunch of columns. And the 2 rows correspond to 2 countries, and the columns correspond to GDP per capita, which is the amount of economic output per person in the country in a particular year. Okay, and these numbers are what's called purchasing power parity. If you're wondering, like, what are the units of these, because the value of money changes across time with inflation or deflation, and it changes across countries in a different point in time. So like if you take a $1 US in the United States can purchase much less than $1 US in Bangladesh, for example. And even in countries like Australia and New Zealand, which are relatively similar in many respects, a US dollar in Australia, when converted to Australian currency, versus a US dollar in New Zealand converted to New Zealand currency, different purchasing powers in those countries. And then of course, the purchasing power changes across time. So these numbers are adjusted to account for those differences. So we can make these kind of cross time and cross country comparisons when we start comparing things. Okay. Right. So this data frame, many CSV files have a column which is like the natural index. So 0 and 1 are the indexes that are created for the rows in the CSV file. But actually our rows are uniquely determined by the country column. So we can just put index call equals country. And now we get a data frame where it's indexed by country. And so this is useful because in Pandas, you can index things by labels. So you can put in like Australia, New Zealand, or GDP per cap underscore 1952 to select out rows or columns of data. We're going to see how to do that in a minute. Now, this read CSV file is one of the first kind of what I'll call it a real world function, where the function signature is quite complicated and has a lot of options. And learning how to use this read CSV file efficiently is one of the things that there's almost a whole chapter in the Introduction to Python for Data Analysis book that Wes McKinney wrote on how to effectively use the read CSV file. It has to handle a lot of cases because CSV files are a very common data format, but each CSV file is slightly different in its own way. It might have a different delimiter, it might use quoting, it might have bad lines in it, it might have all kinds of weird things that can go on in CSV files, and this function needs to be able to handle as many of those cases as possible. Thus, it's quite involved. We're only going to use a little bit of its functionality today. So Sammy asks, we're getting text files from spectrometers in our lab formatted in a different way. So how could we get these text files converted into a CSV file? So, and the answer, which looks like Mohammed is providing partially in the chat right now, is that a text file can be read in by this read CSV file. It's probably the case that your text files have a different formatting. So maybe they're using not a comma as a delimiter between the columns, but maybe a tab or a semicolon or a pipe character. These are common delimiters. But as long as there's a consistent delimiter, then you could use the read CSV file to import this data. But if you have, Sammy, if you're here at KAUST, then you're more than welcome to reach out to me via email or Slack and with a specific example of that text file, and I can probably set you straight pretty quickly on how to import it with read CSV. Or if it cannot be imported with read CSV, I could probably tell you that as well. But the chances are pretty good that it can be imported with CSV, read CSV. Okay. So back to our data frame. So our data frame, you can get some information about the data frame. And the data frame will tell you basically, how many columns and how many rows, and how they're indexed, what types of data are stored in each column. So all of these columns are numbers, so they're floating point numbers. There are no missing values, so it's very common to have missing values in tabular data, but in our case, we don't have any missing values. Also tells you something about the memory usage. So this is, this might be important. So if you have a laptop that has 8 gigabytes of RAM, then the largest CSV file that you're going to be able to read in might be about 4 gigabytes. Maybe a little larger, depending on what else is going on in your operating system, in terms of reading it into a Pandas data frame. But a lot of the complexity of the read CSV file is handling the case when the CSV file or files are too big to read into memory at once. And you need to do what's called chunking and only read and process a chunk of your CSV file at a go. That's more advanced than what we'll cover today, but it's a very common use case for read CSV. You can look at the columns of your data frame by accessing the columns attribute, which just gives you the column names as an index object. Data frames are two-dimensional data structures, so you can kind of think of them as a two-dimensional array or a matrix and transpose them. So swapping rows for columns. There's a handy describe method that you can use to calculate summary statistics of all of the numerical columns in your data set, in which case is all of our columns here. So that's really handy. Okay, so let's take a few minutes, so 3 minutes, and have a look at these exercises. So there's some examples of, I'm kind of jumping all over the place here. So reading other data files. So definitely be sure that you understand how to read in the data files. That's really important. So make sure that you can read in the other data files. And some of them are larger than others. Like this data frame for Oceania only had 2 countries, but obviously like Asia, Africa will have larger data frames. There's another CSV file that is for the whole world that has a slightly different format if you want to explore what that one looks like. There's some exercises here that explore different methods like head and tail to figure out what those might do. So take a few minutes and look through those exercises. And then I'll just stop sharing briefly, and you guys can ask me some questions if you have any questions. And then we'll move on. So I realize it's about 3:15. So I believe that prayer time is in like roughly 15 minutes. So what I thought we might do is I'm going to quickly kind of go through the next episode, which is just a little bit more about Pandas data frames, and then we'll take a break from 3:30, 3:40, maybe like 3:40 for 20 minutes. We'll take a break from 3:40 until 4 o'clock, and then we'll come back and at 4 o'clock and do another hour and see how far we get. So hopefully that works for everyone. So there's a question in chat from Najat. So why would we want to treat columns as rows using transpose? So we'll see this in a minute, or we'll see one potential use case in a minute. But so data frames have actually a plot method where you can just plot them. And so here, if we just call the plot method on this data frame, we get something that looks really weird. Like we get, like this just doesn't look like what we would expect at all. Like what we really want to plot, if we look at our, if we were to look at the df, head command, we really want to plot the Australia and New Zealand, their GDP per capita across time. So we want to not plot the columns, which is what's happening when you just call df.plot, but we want to plot the rows. So we could do df.transpose.plot, and then that gives us kind of the plot that we probably want. But alternatively, you could say, well, maybe we should just reorient this data frame so that actually the countries are the columns and what are the columns are the rows, and make that the actual permanent orientation of the data frame. And so we could do that. So if you did df equals df.transpose, now your data frame would look like this. So you can look at the first 5 and the last 5, something like this. I'm actually going to put it back again because I want to use it as
excuse me,
rows.
Share your screen.
Oh, sorry, we can't see your screen.
Thank you. I'm glad that somebody interrupted to remind me. So thank you. So where was I? So okay, so I changed the orientation of the data frame by just reassigning it to that variable, but calling the transpose method. or actually no, before that. So if we plotted the data frame when it's oriented like this, rows and columns, it plots the columns by default. And so here we get this like nonsensical graph. But here, if we transpose it and plot it, we get what we want, which is kind of the GDP per capita across time. We're going to do a lot more plotting later, so don't worry too much about this looking a bit ugly. So here, then I reset it back to, or then I transpose it and then reassign it to the variable. And now if you call head and tail from the exercise that you may have done, head pulls out the first 5 by default rows, and tail pulls out the last 5 rows. And so now you can see that the data has changed its orientation. And then I can put it back again by just transposing the transpose. And then now we're back to where we were. So it kind of depends on what you want to do.
Wouldn't it be better if you assign it to you a new variable so you can use either one of them?
Yes. So in general, we'll see some more examples of this in the next episode. But yes, you're absolutely right. Typically, you better off not overriding your variable names like that. So I was just doing that kind of quickly because I was trying to demonstrate something in response to questions, but you're absolutely right. Okay, any more questions before we move on? Okay, so moving on. So what I want to do is try to quickly cover the indexing and selecting values from Pandas data frames. And then we're going to take a break for about 20 minutes for prayer. And then hopefully we'll come back at 4 p.m. and then we'll carry on for another hour. So I've got to get through this in 16 minutes. Okay. So selecting values. So there's 2 ways that you can select values in Pandas data frames. You can select them by integer location, so like the integer label for the rows or the integer label for the columns, or you can use the actual labels. So now I'm going to read in a different data frame. I'll call this Europe data frame. And I'm going to read in from read CSV data Gapminder Europe CSV, and the index column is going to be the country. And I must have made a typo again. Yes, I forgot the GDP. Okay. And so if we look at the Europe data frame, the first few rows, it has the same structure as before. So the countries are the row labels, and then these GDP per cap in a particular year are the column labels. So we can access data by index label, or by integer label, sorry, using the iloc method. And instead of parentheses, we actually use square brackets because we're selecting. So we're selecting the 0th row and the 0th column and returning the value, which is, in this case, the value for Albania, GDP per capita in 1952. Now, I almost never use this, the iloc. Instead, I prefer to select data by labels, because these integer labels, so like 0, 1, 2, 3, da da da, and 0, 1, 2, 3, da da da, are arbitrary, right? I mean, there's no reason why these countries have to be ordered in the way that they're ordered. So it makes more sense to use label-based indexing, which is what you get when you use the loc method. And here we'll put Albania, which is a country label for the row. And then for the column label, we can put GDP per cap and say 1952. And variable not defined, Europe data frame, df. So this, using prefer label-based indexing and slicing. So this to me is much more explicit about what data you're selecting. And typically you're selecting a subset of data that you're then going to use in some calculation. So you want to be able to look at your code and see what you're doing. Whereas this tells me nothing about what this value represents. So definitely you should prefer label-based indexing and slicing. You can use, just like when we were slicing with strings and we were using a colon to represent the entire kind of slice or the entire string, we can do that here. So if we wanted to select all the countries at a particular point in time, for cap 1977. So this is selecting all the countries at a particular point in time. So I'll put a little note here. Select all countries in a particular year. So select data for all countries in a particular year. And similarly, we could do select data on data for all years for a particular country. So let's do Europe, data frame, loc. So a particular country, let's go with Germany and all years. So we'll put a colon there. Okay. So Germany per capita and GDP per capita in 1952 was only 7,144 US dollars. But that's to be somewhat expected because this is less than 5 years after the Second World War ended. And then obviously its GDP per capita has gone up by not quite a factor of 5 since then. Okay, so what else? So we can do multiple, you can kind of slice up data frames. So for example, if we wanted to go from Iceland to Serbia, and from GDP per cap 1957 through GDP per cap 2002. So we can use the colon to indicate ranges as well. But remember, unlike the slicing that we did earlier, which went from including start up to but not including stop, here we do include the stop. So Serbia, for example, is included, as is GDP per cap 2002, which makes sense because when we're doing calculations with like lists and arrays and that kind of thing, we usually don't want to include the endpoint, but when we're selecting data, it makes sense to include the endpoint. So Pandas does kind of the expected thing in this case. Right. Okay. So you can use the output of slices in calculations. So if we wanted to call this subset data frame, then we can use the subset data frame, and we can do things like describe this subset. We can do the max and compute the max across the rows for each column. What else can we do? So we can create conditional statements. So subset data frame is greater than 10,000. So this is going to return a data frame that has the value of true if the GDP per capita for a particular country in a particular year was greater than 10,000 US dollars. So for example, in 1957, Norway had a greater GDP per capita greater than 10,000. So that is true, whereas other countries like Italy, Ireland, and Iceland did not. And so they have a value that's false. So if we wanted to actually get the values, instead of true and false, if we wanted to have the numerical values for which this condition is true and missing numbers otherwise, we can use, we can actually assign this to a variable. So we can assign this to a variable called, I'll call it is relatively rich. And then we can use the subset, and now we can use just square brackets on their own, and then select is relatively rich. Or we can use is relatively rich to select the values from subset for which that is true. Oh, not defined, subset data frame. There we go. And so what you can see is wherever this was true, so Netherlands and Norway in 1957, has been replaced with the actual numerical value from the table, or from the data. And then where that value is false, it's just filled in a missing value. And that's sometimes useful because if you wanted to compute some descriptive statistics, but you only wanted to include the values of countries that were relatively rich, then you could do something like this. And so you can see here in 1957, we're computing these descriptive statistics only for these two observations here. So that's why the count is 2. And then in 1962, we get Iceland, so that adds a third observation. And so now these descriptive statistics are computed over these 3 observations, and so on. Then by the time we get to 2002, you know, most of the countries are included, and so we have 7 out of the 10 countries. Okay. We're going to end with a slightly more involved example of the group by split, apply, combine paradigm, which is a very common way of doing what's called extract, transform, and load ETL workloads in data analysis. So we're going to take the rows in our data set and group them by a particular condition. And then once we have grouped our data, our rows into different kind of bins based on some condition, we're going to apply a function to each of those bins, and then we're going to combine the result at the end. So, for example, if we started off with a question where we wanted to see how we could group up countries in Europe depending on whether they are, you know, relatively poor or relatively rich. Yeah. So one of the things that we could do is we could say, okay, well, if we compute the mean, then this is going to compute the average GDP per capita across all countries in Europe for each year. Yeah. And we can see the average GDP per capita across Europe has gone up, as you would expect. But if we wanted to say, like, well, a country is relatively rich if their GDP per capita is greater than average. So that's what this is saying. So I'm going to call this is relatively rich. Okay. And if we look at this, we can see now this is saying that in 1952, Albania's GDP per capita was lower than average for across all the countries in 1952 in Europe. And so it gets a false. Where a country like the UK was had a GDP per capita that was higher than the average across all European countries in 1952, and so it gets a true. And then you can compute, or you can work out true or false for all the other countries and all the other years similarly. Okay, now what we can do is we can say, okay, well, how many what if we take the sum of this data frame? Well, the sum of this data frame, actually, maybe I will do this. If we take the sum, so this is going to sum across the columns, and where you're summing trues and falses are going to be treated as ones and zeros. So you're summing these ones and zeros. So what you're really doing is counting the number of countries in Europe for which this is relatively rich condition was true. Yeah. And so you see that there are 13 countries for which that is true in 1952, and 17 countries for which that was true in 2007. Yeah. But what if we compute the sum not across the first axis or the 0th axis, which is the row, but if we compute the sum across the axis 1, which is the summing across the columns. Let's see what we get. Okay, so what we get here is for each country, we get the number of times its GDP per capita was greater than the average of the GDP per capitas in Europe in that year. So a country like Albania has never had a GDP per capita that was greater than average. Whereas countries like Austria and Belgium, which are intuitively wealthier countries in Europe, do have 12 examples of when that was true. So if we were to use, instead of a sum, we could compute the mean. And this would basically just normalize these integers by the number of countries that were in that year. And so this is doing the same calculation, but slightly different than the way that it's done in the lecture notes. But it arrives at the same result, I think a little bit more cleanly. And we can use these numbers now to group the countries. So we've computed this kind of what they call a wealth score. But we've basically just used a bit of data analysis to compute a metric for which we can group these countries. So countries that have the same wealth score will be grouped together. So Albania will be grouped with Bosnia and Herzegovina and Bulgaria and Croatia, whereas countries like the United Kingdom, Sweden, Switzerland, Netherlands, and Norway, France will be grouped together. Germany. Okay. And then what we can do is now we can do this group by. Now that we have something to group by, group by key, we can group our data frame and then I'll compute an average. Group by. And so now what we are getting here is the average GDP per capita in 1952 across all countries whose wealth score was 0. So that's basically including only so all these countries that have a 0 wealth score, I average them up. This calculation averages their GDP per capita in 1952 and returns a result. And this value takes all the countries who had a wealth score of 1 and computes their average GDP per capita in 1957. And that turns out to be $10,611. Okay. So there are some exercises here, which I leave as kind of exercises for you during the break, if you want to look at them. I am very conscious that I want to allow some a break for prayer time. So we'll take a break now, and we'll come back in 20 minutes, so just a little bit after 4 o'clock, and we'll pick up and see how far we can get basically in that last hour on just continuing this theme of data analysis in Python. Okay, so I'll hang around. I'm going to save and stop sharing my screen. I'll hang around for a minute, just if anybody has some pressing questions. Otherwise, I'll pause the recording and take a break myself. So I'll see you at just after 4 o'clock. Okay, any questions? Last chance before I go on my break. Nope. Okay, all right, well, I will see you guys in about 15, 20 minutes. Okay, so welcome back, everybody. So we've got a little bit of time left, so we're gonna get right back into the teaching. So I'm gonna share my screen again. And so here is several people have asked about this, so I wanted to share the link to our YouTube channel. This link will go out tomorrow as well when I posted the video for today, but I'll go ahead and share the link and chat with everybody since several people have asked for it. And we'll get back to teaching. Okay, so we're going to pick up with the next episode on plotting. Okay, so plotting is a very common thing, obviously, that people that wants to do with data analysis is plot some results. So we've seen a little bit of plotting already. So the standard plotting library in Python is matplotlib. And the standard import is to import matplotlib.pyplot as PLT for plot. Now the lecture notes has this kind of matplotlib inline command, which isn't necessary any longer, so you don't need to worry about that. So if we wanted to use a simple plot, we could do something like we could create these are called Python lists, but basically just a collection of things to plot. So time points 1, 2, 3, 4, and position, and we could plot 0, 50, 150, 300. Well, whoops, I'll put all this code in one cell. And then we could do plot.plot of time and position. And then we can set the X label to be time in hours and the Y label to be position in kilometers, something like this. And we could also do plot.title is, our first plot. Right, I only have, so this has 5 numbers, and this only has 4 numbers. So that's why the error is saying that I can't plot. If I'm making a 2-dimensional plot, I need to have the same amount of numbers in both samples that I'm trying to plot. So the first one has 5 and the second one has 4. So I will add so we get something like this. Now, okay, so matplotlib, fantastic library, been around for quite a while. Great documentation, loads of examples. I learned how to plot in matplotlib by kind of just going through this gallery of examples and then looking for a particular plot that I wanted to kind of replicate. And then, so like, here's an example of, plotting different aspects of some time series of a signal, converting it into the frequency domain, and then plotting different things, aspects of it. And so then there's code here that shows you how to do that. So best way to learn matplotlib is by going to the documentation, finding an example, running the code. So like in particular, we should be able to just copy this code. So I'll click this little copy icon here, copy it. And then, so pasted example from matplotlib gallery. And so there's the code. So I will put the link to that. Take advantage of having the markdown cells, and I'll just embed a link in the notebook. And then you'll have this link later when I upload it to GitHub. So this is more involved. It has, several subplots, different colors, labels, things like that. Right, okay. So we can plot data directly from a Pandas data frame. So what we're going to do is we're going to work with our, well, let's use a different data set than what they use in the lecture notes. So we haven't worked with Asian data yet. That will allow us to look at Saudi Arabia if we want. So let's do that. So we're going to read CSV data Gapminder Asia GDP. No, Gapminder GDP Asia .csv, and the index column is the country. Okay, and let's look at the first few lines. So there's our first few lines, Afghanistan and China. We can look at the last few lines with tail. So Yemen, Taiwan, and let's look at we can describe, so these are now computing descriptive statistics for each year. If we wanted to So we can also do descriptive statistics for each country. Here's another example of where transposing the data set comes in handy. So we can transpose the data set, and now we can get descriptive statistics for each country. Okay. So what did I want? So this is on plotting. So let's look at from our data frame, we want to select out a particular from our Asia data frame, we want to select out a particular country. Let's do Saudi Arabia. And we want to use all of the years. Okay, so here is the GDP per capita in Saudi Arabia for all of the years. And then let's plot. So we can, so this is a technique where, so we could write this, we could just do this. And so this will plot GDP per capita for Saudi Arabia across time. Yeah. It's a bit messy down here, so we're going to talk about how we can clean that up a little bit. We can also do something called, so this is called method chaining, where we're calling dot loc followed by dot plot followed by any other kind of thing. I tend to like to line these things up on the dot just to make it more visually concise. And so in order to execute a multi-line command in Python, you need to surround the command in parentheses. Yeah, so Python is white space sensitive. And so we need to make sure that it ignores this white space here, and we do that by adding these parentheses. And we can also add, since this returns an axis subplot object, we can actually just use this underscore to capture this axis subplot here so that it doesn't get printed into the screen like this. So we're just kind of iteratively refining this, this diagram. So one of the things I want to do is kind of go back up here to where we loaded the data set and clean it up a little bit. So one of the things we want to do is basically strip out this GDP per cap in 1952 and clean up so that instead of GDP per cap in 1952, it just has the year 1952. So this is kind of an example of data cleaning, data munging, data wrangling that you often encounter in doing data science and machine learning, and what's called extract, transform, and load, or ETL kind of workflows. You need to do quite a lot of this type of stuff. So we're going to take our Asia data frame and look at the columns. Okay. Now, the columns have a way to access the strings. So each of these entries in the column index is a string. So there is a string method that allows you to access and apply string methods to each element in the column. And so what we can do is we can actually strip out from the string the beginning GDP per cap underscore. And that leaves us with strings representing these integers. And we can get rid of that by using an asType method to cast these strings to integers. And now we can reassign the columns value to be this new index that we've created. So Asia. And now we've gotten rid of these messy GDP per cap 1952. And what this means is that now our data looks a bit neater, but also our plots are going to look cleaner. So now we have just the years down here, which makes a lot more sense. Okay. So we can add. You can go in here and add labels. So we can do plot dot x label as time, or maybe year. Y label as GDP per capita. Okay. And again, each of these methods returns a value, so we can just kind of suppress the return values so that we get rid of that printing the type to the screen, I guess, or not to the screen, to the output, notebook output. Okay, so there's lots of different plot styles that are available. So this is kind of the default matplotlib color scheme, but you can change the style. So there is a color scheme in R called, there's a plotting package in the R community called ggplot, and it has a color scheme that's very popular. So you can change the plot style to ggplot, and then we could do this same plot again. So that gives us a slightly different plot. What else could we do? So there is even another plot style. What's it called? That's not it. So style.available. So there is another style that I wanted to show you, which I kind of like, but I've got the name wrong. So let's see if I can figure this out. So see style.available. So plot.style.available. And so this is giving the list of everything that is available. And so they have different kinds of ones that are available. So Seaborn is another plotting library that has a lot of color schemes. And so they've built in a lot of Seaborn color schemes if you like those. So there's the ggplot one. 538 is a color scheme from a US politics blog. So let's try that one, see what this one looks like. Yeah, so that's a slightly different style. So one of the things I didn't show you about JupyterLab is you can rearrange the order of the cells by kind of dragging and dropping. So I can drag this cell up here. Oh, where'd it go? Let's try that again. Plot.style.available. And I can drag this up here. There we go. Oh, somehow it got up here. I'll just delete it. Okay, so here is a list of the available styles. So you can look at some of these others and experiment with yourself to see which one you might like. I'll just save that. Okay. So you can customize. I'll try a different one. here. Well, let's go back to well, I'll switch to Seaborn. You can customize this by passing in arguments into the plot method directly. Or you can plot data from, you can plot data from the data frame directly. So instead of calling this plot method, what we can do is we can do like a plot.plot of data Asia data frame dot columns, and then the data here, and then we could make the line to be a green dashed line. Asia, yeah, but typically I would just use the plot method on the data frame and not this way. But just kind of showing you. You know, we could plot many lines together. So if we wanted to do, like, if we go back to this this way, and then did Saudi Arabia, and so what would be a country that starts with less than S and goes to Saudi Arabia, but not maybe not too many countries. So all right, well, let's look at it like this. So Asia data frame, and we can look at the index to get the countries. So Saudi Arabia is here. So if we did Saudi Arabia to, we'll just plot the S's, Syria, and then plot them for all the years. That's not what we want. We want to transpose this. So we want to do, first we select out the data, and then we transpose it, and then we plot it. There we go. And so you can see how much Singapore's GDP per capita has grown over the last 50, 60 years relative to you know, Sri Lanka and Syria, who are way down here, and then Saudi has had a much more mixed experience, where we had Saudi had lots of growth in GDP per capita, and then things have kind of gone down. Okay. What else? So some scatter plots. So there's some more plotting examples in here. I'm conscious of the time, so I don't want to spend too much more time, I think, plotting examples, but I do want to give you some time to play around with the exercises. So I'll go ahead and set my timer. So if you want to take a few minutes and play around with some of these plotting exercises, please do so, and I will just answer some questions if you have any questions. There's some really interesting exercises that are worth looking at: correlations, more correlations, and even more correlations, I think, are good exercises that walk you through not just a lot of plotting. So Muna is asking a question: the dash, or you mean the underscore equals? So, okay. So let me share my screen again. Okay, so Muna is asking a question about what is this doing? And it's not necessary. So so the thing is that each of these functions that I'm calling return an object. So if I instead change this to A, B, and C, then if I look at what is A, well, A is actually an axis subplot object, which is basically returning the object that stores this plot. B is an object that represents the text associated with this X label. So it's basically a position, a position in the X. I'm not sure what this is, maybe the font size and then the actual font itself. So and then C is the same, but for the Y label, Y-axis label. So if you needed to get a hold of either the plot itself or the X-axis or the Y-axis, then you can store these objects and then do things with them. But typically you don't necessarily need to do that. And so what I do is I put these underscores here, because if you just leave them off entirely, then what gets printed is this thing here, which is this here, C. And I don't like it to be printed in the notebook because it kind of clashes with this nice graph. And so one of the things that you can do is you could just put an underscore. This underscore will then capture that last object and pretend that it's like a Python variable almost. It's a bit of you can think of it as just a hack to avoid something getting printed that I don't want to get printed in the notebook. But I tend to started doing it as a habit, to where if any function, like plotting function, kind of returns an object that I don't care about, I just put this underscore here to capture that object, but in a variable that I'm not going to use. So hopefully that answers your question. Okay, any other questions? If not, then just bear with me 1 second. Okay. Then what I've done, let me share my screen. Okay. Then what I've done here is I've copied the code from more correlations, which is plotting this data set for the entire world. And I'm going to walk you through it and kind of just explain what's going on. Okay. So what we're doing here is we're loading this data frame like we've been doing all along. But now we're creating, and this is an example of creating a scatter plot. And here we're passing in, so now that I've loaded in this data all data frame, let's take a look at it. Okay. So this data frame has countries and continents, and then GDP per capita, and then it has some other information as well. So population and life expectancy, the other variables. So what we're plotting is a scatter plot of GDP per capita in 2007 and life expectancy in 2007. And then the size of the point in the scatter plot, we're making it being proportional to millions of people. So that's the data all, and actually this should probably be loc in here, just to be more specific. Yeah. Oh, oh, right, because it needs, there we go. Okay, so that's just an example of a slightly more elaborate plot. If you read through the documentation of the plot option, then you can find out kind of what all of these things does. So here you can see the different kinds of plots. So we use scatter plot. We have been making line plots, which are the default, but you can have other kinds of plots as well. And then the X and Y is a label or position from a data frame. So that's why we used a label, GDP per cap and life expectancy. And then if we go through here, there should be something about S, which is being the size of the keyword options. So looks like you would have to dig into the documentation for the matplotlib plotting method to find what this S does, but the S is for the size of the scatter. And I don't think that you can just pass in a label here. I think you actually have to pass in the data. So this part is possibly not data frame aware. Let's see. Oof, so it is, but that doesn't do what we wanted. And probably the reason is that population is in numbers of people, which is really big. And we need to rescale that by dividing by 1 million in order to get a sensible scale. So I'll call this marker size. And then just to remind you that S is marker size. There we go. Okay. All right. So let's move right along. So we're doing pretty well. We've got about half of the material covered, and we only had half a day's workshop. All right. So what I would like to do now is jump ahead quite a bit, because I want to stick with the theme of data analysis. So I'm going to jump over this episode on lists. So lists are a very important data structure in Python. We're going to use lists for the last episode that I'm going to cover today, but I'll just mention the key features of lists as I go along. And if you want more practice with lists from the basics, then please come back and take a look at this episode. Similarly, I'm going to skip for loops, in part because I'm going to use for loops in this last episode that I want to cover with you. And I'll try to explain the key features of for loops as I go along. But if you want from the basics details, then please come back and take a look at this episode. And similarly, I'm going to skip conditionals, and I'll talk about conditionals as we, the syntax of conditionals if we need them in this episode. this is what I want to spend the last 15 minutes or so with you before we take questions on, because it's a nice follow-on to the data analysis work that we've been doing so far. Looping over data sets. So a common task that you will have doing scientific computing, data analysis, data science, machine learning, whatever it is that anytime you're working with data, is you're going to have lots of data sets, and you're going to want to do a similar task to each of the data sets. And this is how I'm going to show you kind of how to do that with for loops and conditional statements and data loading here with Pandas. Okay. So let's suppose that we want to load a bunch of data sets, and then we're going to do some analysis on each of the data sets. So we have Pandas is already imported, and we know we have some file names. So file names. So I'm going to create a Python list, and a Python list is just a collection of things in Python. It's created with square brackets, and then in a list can have different types of objects. So it could be strings and integers, or integers and floating point numbers, or any kind of object can be included in a list. In this case, we're going to have a list of strings representing file paths. So we'll put file paths data, Gapminder, GDP, Africa, CSV, and Gapminder, GDP, Asia, CSV, and this should be data. Okay, so we're going to have a list of file names. Now, this only has 2 file names, but the same principle could apply if there were 1 million file names or something like that. Obviously, it would just be really annoying to write all those 1 million files out in a list manually, and I'll show you in a moment how to automate that process. But now we have our list of file names. We want to process these file names using a for loop. So in Python, the syntax for a for loop is for some variable name, which is called the loop variable, in a collection of things, typically but not always a list, that you want to process. And I will call this file names. So for file name in file name. So each time through the loop, the file name is going to take on one of the values in the list of things that we're iterating over, or that we're looping over. So first it will take this, and then it will take this, and so on and so forth. And we can test that by just putting a simple loop body, so the code that is indented 1, 2, 3, 4 spaces underneath the for loop is called underneath the for line is called the loop body. And here, let's just print out the file name. Okay, and this colon is important. So don't forget this colon. So the things that are important syntactically is the for, the in, and the colon, and then this indentation. But if you put the colon, then IPython or Jupyter will automatically give you the indentation. So if we run this code, then we go through and print the file name each time. Okay, so that's fine. So let's do something besides printing the file name. Let's actually load the data. So we're going to read CSV from the file name, and we're going to use the index column is country. And then instead of printing the file name, we'll just print df.head. So the first 5 rows of each data frame. So now this is taking a little longer because it has to load, but now it's printing the first 5 rows, and it has to print all the columns. So notice that you get basically Algeria, Angola, Benin, Botswana, Burkina Faso, and then these are the first 5 rows in the Africa CSV data for all of 2000 till 2007. And then why did it not load? what happened to the Asian countries? You can tell that I'm tired because I'm not reading properly. So here are the African countries, and now this is the Asian countries. So that's the second data set. Maybe we could even set that up more particularly by saying print file name. And now, so here's the Africa data, and then here's the start of the Asian data. Okay. Now, this is a bit annoying in that with two data sets, it's okay to write out all the names manually, but it would be better if we didn't have to do that. So one of the things that we can do is there's a library in the Python standard library called glob, and you can actually use glob to extract file names that match a certain pattern, because this is a common thing that you want to do in data analysis. So if you look at these file names, the pattern is that they all start with this, and they all end in this. So we can replace this with a star, just like we did with wildcard pattern matching in our shell course. And now glob.glob is going to grab Africa, Asia, Americas, Europe, Oceania, Asia, and those are all of the files that were there, except for the Gapminder all data set, which doesn't match that pattern. So here we have 5 files that match that pattern. The Gapminder all is a different pattern, even though it's a CSV file. So it's not included in this, and it doesn't match that pattern there. So it doesn't end up in file names. This is super handy. If you, I can't remember, someone here, one of the participants was talking about reading data files that were text files off the spectrometer. That machine might generate, I don't know, thousands or hundreds of thousands of data files. And you could grab, if all of those were in a set of directories, you could grab all those files at once and start processing them with a for loop using this kind of idea. So it's very, very powerful and very useful. Okay, so, okay. So that is about as far as I think we're going to be able to get today, because I want to leave some time for Q&A and to talk about the other episodes in the Python lessons I didn't get to discuss. So are there any questions about what I just covered? Okay, so how to convert a notebook to a script. This is a very good question. So Dahlia has a question about converting a notebook to a script. And there is a tool for that. I don't often use it, so I need to think for a minute about what's the best way to show you how to do that here. So okay, so let me share my screen again. So let's suppose that I went through in this notebook and I created a whole bunch of analysis that I prototyped and tested interactively in the notebook, but now I want to convert it to a script that could run as a batch job. So the way that you would convert it is you can go to File, Export Notebook as, and then Executable Script. and actually, this is going to export it from inside the Jupyter server down to a file that you can store on your desktop. So if I just called this sandbox Python script, so you could save it. So this is going to basically export the notebook as a Python script onto your file system, which might not be exactly what you want. But that's one way to do it. Another way is there is a command line tool. Just give me a moment to look it up, which will convert. Right. Let me just test this real quick, and then I will make sure that it works. Okay. Yep. Okay. Okay, so the question was, how do you convert an IPython notebook or a Jupyter notebook to a script? And you can do that using a tool called Jupyter NBConvert. And so if you create a terminal, I'm just going to clear this. All right, let's see where we are. So we're in our home directory. So if we change into our introduction to Python directory, and then we want to go in the notebooks directory. Okay. So I just tested the tool. So there's a sandbox.py script there. So I'm just going to remove that. Okay. So now the tool is called Jupyter, which you can launch a Jupyter server with Jupyter Lab. But now we're going to use another subcommand called notebook convert, NBConvert. And if you look at the help menu for this command, it has quite a lot of things that you can do. So you can convert your notebook to PDFs, to HTML, to Markdown, or to LaTeX. There's a whole ecosystem of tools designed around using this command to take a notebook and maybe compile it into a paper, into a PDF paper and LaTeX, or all sorts of stuff. Writing books with Jupyter notebooks, they use this tool. We just want to do something really simple, which is basically export the format to a script. So the way that we do that is, I'm just going to clear this now, is NBConvert to script, and then we need to add either the path to the notebook that we want to convert. So sandbox IPyNB is what we want to convert. And we hit enter, and now our notebook has been converted to a script, And if we look in the Introduction to Python notebooks directory, so here's our sandbox.py script that we just created. And if you just take a look at it, what has happened is effectively all of the stuff in the notebook has been somewhat commented out. And the only thing that's left is basically the input code cells. And so now it should be possible to execute this script, and it would just run these commands one after the other until it either hit an error, like this would have been a syntax error that I demonstrated during an earlier episode this afternoon. But if this was an actual, notebook that all the code worked from top to bottom, then you could just run it as a script and you'd be good to go. So maybe if I wanted to, let me just make a simple demonstration of that. So if I just create a new notebook, and I will call this, I'll rename it and call test notebook to convert to script. Okay, and in this test notebook, I'm just going to do two things. So I'm going to import, I'm going to import the math library, and then I'm going to do math.cosine of math.py. What does this do? Part of the square root of the input. That's not what I want. And then print math.cosine of math.py. Okay. So when I execute this script from top to bottom, it imports math, it runs this command, which in a notebook prints out the result. And then I print the result of the same command, and then it prints the result. And what I want to show you is that when I compile this to a script and run it, I think that only this is going to print because there's a manual print statement here. This is going to be executed, but won't print. So let's test this. So we'll go back to our terminal, and we will do Jupyter NV convert. It's hard to type with a laggy keyboard. NV convert to script, and then test notebook convert to script. Okay. And now if we go over here and refresh, so here's the script that we just did. And now if I create an IPython console, then I should be able to run the test notebook convert to script. Yeah, and notice that instead of having two -1s, only that second -1 actually printed out, because if we look at this script, then this is the script that was created from this notebook. So you can see what happens is that when this script gets run, we import the math library, we execute this code, but we actually don't do anything with the result. So that result is not going to be displayed anywhere. It's just computed and lost. And then we actually print this out. So that's why even in the notebook, we see two outputs. And when we run the script, we only see 1. So that's important, because if you forget those print statements, if you're creating a notebook that you want to convert later to a script, make sure you use print statements, because that will ensure that what you think is going to get printed will actually get printed when you run the script. So that's a very thorough response, but hopefully that answers the question. I guess one other thing is that you can execute. So I showed you how to execute a Python script from a console, but you can actually also execute Python scripts from the command line too, by just running Python and then the script that you want to run. So that's another way to execute the script. Okay, any other questions? So Moaz is asking, is there a way in Python to set a folder path for data instead of writing the path every time? So I can't think of anything off the top of my head that I would want to publicly advocate for you to do. Let's put it that way. So I could think of a few hacky ways that might work, but I don't think they would be good ideas in general. And so I don't want to lead anyone astray by suggesting something at 5 in the afternoon after a long day's worth of teaching that might end up to not be a good idea. So I won't. So sorry, I don't have a good answer for that one. I guess real quickly, what I want to do is encourage you. I know we didn't get a chance to cover everything, but the important things from afternoon are, I would say, writing functions. Or of the remaining lessons, the writing functions is one that's really important, because you will need to write a lot of Python functions. And so this covers the basics of how to define and write your own functions, functions that don't take any arguments, functions that take arguments and keyword arguments and things like that. So functions, lists, for loops, and conditionals are kind of the main topics of kind of the Python language that we didn't get to cover today. We focused more on the data analysis part of things, which is intentional, because in 3 weeks' time, after we cover Git and SQL, we're going to do an introduction to scikit-learn, machine learning with scikit-learn, and then an introduction to image classification with Keras. And in both of those lectures, we're going to need to work with data more than we're going to need to be writing for loops and conditionals and things like that. So I left these out because, not because they're not important. They're all very important. I would encourage you to take the time to go over them in your spare time. Okay, and if you're really interested in a deep dive to Pandas, definitely check out both the Pandas documentation, but also volume 2, or not volume 2, second edition of the Python for Data Analysis book. It's really great. Okay, that's it for me. I don't have anything else. I want to thank the team from MyBinder and BinderHub, who provided the computing resources that we used today. It would really not have been possible for me to teach a course like this to this many people spread across the region without the support of MyBinder, and then for the research computing here at KAUST for providing the KAUST BinderHub instance for use by KAUST participants. So hope you guys learned a fair bit about Python. I'm sorry we couldn't cover everything. And we'll send out a link to the YouTube video tomorrow as soon as it's posted. Also a feedback form. So please complete the feedback form. It gives us great information on how to improve the course for next semester and any future courses that we're teaching this semester. And look forward to seeing you next week or in some future KVL data science training. So thank you very much. Bye, guys.
Will there be there another session next week?
So yeah, so next Tuesday afternoon, we'll be covering Introduction to Version Control with Git. And then the following Tuesday, Introduction to SQL for Data Science. And then I think we have a break because it's spring break here at KAUST. And so we're going to take the next week off, and then we'll come back in the last part of March and early April with the machine learning with scikit-learn and image classification with Keras. So
how we will get the notification? I mean, today we just get the announcement today. I mean, before the session, a few hours before the session.
Oh, are you
so
joining?
Is there a way to?
Are you joining from KAUST?
Yes.
Okay. So tomorrow the feedback link will go out to all of you, and that will include information about registering for future courses. So you can get those links tomorrow. So if you haven't registered for any of the remaining sessions, all the links will come to you in the email tomorrow, and you can register for those. Here at KAUST, we've been advertising these sessions fairly frequently, so in different places. But I think there was an all hands announcement that went out just earlier this afternoon, or this morning rather. So I'm glad you were able to slide in. I probably, personally, if that had been me, I probably would have missed that announcement. But
yeah, I mean, it was the last minute, and I said, okay, I mean, I would like to attend, so.
Sure. So you'll receive an email tomorrow with registration links for the rest of the semester.
Great, thank you, appreciate it.
You're most welcome. Have a good evening.
Too.
All right, bye guys.